Okay,
হ্যাঁ স্যার দেখতে পাচ্ছি।
বাস তাহলে আমি শুরু করছি। Syntax directed translation. So this is the under the semantic analysis page. This is a part of the semantic analysis page. Suppose we give some grammar to the compiler, then compiler need to take some action. So how it can take some action? So that's why we need syntax directed translation. If some syntax are there, then you have to translate, means there is a grammar, there is a production rule. So using the production rule, you have to perform some action. So how that action can be done, that is depend on the syntax directed translation and definition scheme. So here, grammar symbols are associated with attributes. There is a grammar, and say A produces BC. So A is a grammar symbol. So every grammar symbol need to associate some attribute. Every grammar symbol need to associate with some attributes and associate this information for a programming language. Programming language, for this purpose, we need to associate some attribute for the grammar symbol, and then every production that is evaluated, that means every attributes are evaluated by the semantic rule. তাহলে attributes are associated grammar symbol and some rules are there. So using the rules, the grammar will execute and perform some task. And then evaluation, these semantic rules depends on so many factors, so many things they can do. May generate intermediate code, may issue some error message, and so many things. So type checking and others. And an attribute may hold almost anything. Attribute means, attribute is this, that is every grammar symbol is associated with attributes. So that attributes may be a string, a number, a memory location, or a complex record. Now, syntax directed definition and translation scheme associate with, basically there are two there are two scheme. One is called the syntax directed definition and syntax directed translation scheme. So one is called the definition, another is called the translation. These two are required for any grammar to make a semantic rules. So syntax directed definition means what? Syntax directed definition, it gives high level specification for translation, hide many implementation details such as cover of the evaluation of semantic action. So we associate a production rules with a set of semantic action, and we do not say when they will evaluate it. So definition, syntax directed definition means we have to define, we have to give some attributes, and there are two types of attributes. One is called the synthesized, one is called the inherited. So we give some definition of every syntax. And then translation scheme that indicate the order of evaluation of the semantic action. So suppose there are 3, 4, 5 production. So an order which will be do first and which will be second, and how that the production rules will say that. So translation means this is the order of evolution, and in other words, the translation scheme give a little bit information about implementation details. So there is a syntax definition and translation. Basically, there are two notation. One is called the definition, and another is the translation. Definition gives some specification, translation, and translation gives some order of evolution. Now come to the one example. Before that, we say that the syntax directed definition have two type of attributes. One is called the synthesized attributes, and it's called the inherited attributes. There are two types of attributes: semantic, synthesized, and inherited. So again, there should be some dependency graph, and also this graph determines some evolution order of the semantic groups. So I come to the one example here. See the example. This. So this is an example of the syntax directed definition. See the syntax directed definition example. Suppose we have a production. Okay, these are the production, and we have to give some semantic rules. Here, let EL produces E, E produces E1 plus T. These are the production rules. You know that. These are the production rules. And E produces T, T produces T star F, and T produces F, F produces E, F produces DG. So these are the production rules. Now every production there is a grammar symbol. What is the grammar symbol? E, E, F, E. So these are the grammar symbol. So every grammar symbol have an attribute. So this here E dot val, E dot val. So every E has a val, that means value. E dot val means value. So this val is treated as an attribute, and this is the synthesize attribute. Synthesize attribute. And what will happen in this production? See, in first line, L produces E return. So E dot val should be print. When return will encounter, that means their action will be print. So E dot val, the value of E should be print. Now the next production, E produces E1 plus T. Now what is the operation will perform here? That is the value of T and value of E1 will be added and stored into the E. So we can write this way: E dot val equal to E1 dot val plus T dot val. T dot val is a value of T. E1 dot val is a value of T. So val represents here the attribute, and this is called the synthesizer attribute. The value of T and value of B has been added and stored into the E dot val. Again, E produces T. That means what? The T dot val will store into the E dot val. Again, T produces T1 star F. What is the form operation? That is a multiplication operation. So T1 dot val multiply with F dot val, and this multiplication operation will store into the T dot val. So in this way, we associate a attribute with each grammar symbol and write in this way. That is called the semantic rule. And using the rule, the grammar will perform the operation. And finally, digit itself on type of grammatical symbols, but not terminal. This is this is terminal. This is digit is a terminal. So this digit will store somewhere in the symbol table, and the value at that symbol table is called the lex val. That is the entry point basically. So this lex val is will be one type of attributes, synthesized attributes are associated with the digit. So the token digit has a synthesized attribute lex value. It is assumed that it is evaluated by the lexical analyzer. So lexical analyzer in that case, what will happen? Uh, what will happen in the lexical analysis phase? This value digit, the value of digit, is stored into the table. What is the table? Table is called symbol table. So that's why we use it. So this is basically the semantic rules and production. Now, uh, now see, so obviously synthesized and inherited two tables are there, two attributes, two types of attributes are there. One is called the synthesized and inherited attribute, and that using these attributes, we can prepare some semantic rules, and that set up dependency between the attributes, and that represented by a dependency graph, and this dependency graph determines the evolution of order of these semantic rules which perform when that will shown by the dependency graph. And then evolution of the semantic rule defines the value of an attribute, but a semantic rule may also have some side effects such as the printing of value and like this. Okay. So okay, we are confirmed that here every symbol has the attributes, and there are two types of attributes: synthesized and inheritance. And using these synthesized and inherited attributes, we can prepare some semantic rule, and then again we can prepare some dependency graph. Okay, and dependency graphs will say the evolution of this semantic rule, which semantic rules will perform when, that will say by the this dependency graph. Now some annotated parse tree, and using the semantic rules, we can prepare a parse tree, which is called the annotated parse tree, and the parse tree showing the values of attribute at each node. Then it is called the annotated parse tree. And the process of computing the attributes values at the node is called the annotating or decorating of the parse tree. You know how to draw the parse tree. So when you draw some parse tree, then if some values are evaluated and put into the node, then it becomes a annotated parse tree. And of course, the order of this computation depends on the dependency graph induced by the semantic rule. So there is a semantic synthesis definition already I have discussed, but there are some synthesis attribute and some inherited attribute. These are the definition of synthesis and inherited attributes. What is called the synthesis attributes? Synthesis attributes basically are attributes of the grammar symbols in the production. A produces alpha when that B is a semantic attribute. Inherited attributes of the grammar symbol on the right hand side alpha in the production. And there are specific use of their synthesized and inheritors are coming together. And then some attribute grammar also we can design using the synthesized definition scheme. Okay. So now see this example we have already discussed. Now come to the annotated parse tree. See from this particular grammar, if we give some input like this, here 5 plus 3 into 4. So these are the sentence generated from a particular grammar which we discussed earlier. Then how it can be prepared some annotated parse tree. So we can design some parse tree like this. L produces eval then return, and E produces eval plus tval, then T produces tval and eval, and in this way. Now T produces F produces digit, and F produces digit, and finally E produces T produces F produces digit. Now here is a 5 plus 3 into 4. So the lexical attributes from the symbol table of digit, it fetches the value 5. Then it comes to the value A5, again 5, 5 here up to. And also again in the next lexical digit is 3. So that will come from the symbol tables and the F value, T value will be 3. And here also digit lexical 4, so F value will be 4. Now it performs some multiplication operation. What is this? 4 into 3, that is 12. 12 will be uh, just notate and put into this node the value. So this has been synthesized because this value has been shown. The performed value is shown in the node. So that's why this is called the annotated parse tree or decorated parse tree. Then again, this tval and eval will be added using the addition and perform. Then get the 17 and put into this node. So this is eval node. And finally, we print the eval of the 17. So result will be 17. So this type of tree, when we create to check the error, then this is called the annotated parse tree. And finally, using this annotated parse tree, we can create some dependency graph. So what is the dependency graph? The dependency graph is like this. First of all, see the lexical tree. This f value depend on this lexical tree. When if this value is 3, then f value will be 3. Even if it is value 3, then so that's why we just put one arrow. Who depends on which symbol depends on which symbol. So here T is depend on F. Again, F is depend on X val. Then finally, this T value will depend on both T val and F val and multiplication and 12 is here. So using the arrow, we can create a graph which is called the dependency graph. See the dependency graph, these are depend. This value E dot val 17, that is how it can get. So depending on the eval and T val, and then finally the L will be depend on this eval. So this type of graph is called the dependency graph. Another is the syntax data definition scheme also there. There are another example, that is another semantic rules using some location and code. So loc, LOC and code, there are two attributes, and using this attribute we can create some syntax data definition scheme. And here ID is a token. So these are the some synthesized attributes, loc and code, and using this code it can be done. So using this one, some grammar like this, D produces DT L, P produces int, P produces real, P produces L1. So what is this? This is a production where we can write some integer or real, float, ID, ID1, ID2, like this. So these are, we have used here in and type, the two types of attributes. Here type is our synthesized attributes and in is a inherited attribute. So L of in equals to T dot type. If T dot type, say suppose T dot type is integer, then L dot in will be integer. So T dot type is a float, then L dot in will be float. So type means integer, character, float, then L dot in will be such type. Say suppose a T dot type is integer, then L will be integer. A T dot type is real, then L will be real. So these are the type is one of the attribute and in is another of the attributes. And ID dot entry, that is the ID. ID is one of the identifier. Say suppose we have write say int x comma y comma z. Then obviously you can say okay int x is integer, that's okay, but how z will become an integer? Because z is depend on the x. So int if x is integer, then obviously z will be integer. That's why this is id, and that identity will get from the symbol table, and that will be l dot in. If identity comma l dot in, l dot in is the integer, then obviously id should be integer. So add the type. We need to add the type. So for ID, we use add type or function by which the ID will be integer or real, that depend on the T dot type, and T dot type will give to the value L dot. So one, this is basically the example of inherited attributes. Synthesized attribute already we have seen on an analytic parsing, and this is the inherited attributes because int x comma y comma z. So obviously you can say okay x is an integer, but how we can say z is an integer? Because this the it is inherit z, the integer of z. Z will be integer. So how it is possible? It inherit from the x. Inheritance means বংশগতি, মানে মানে উপরের থেকে প্যারেন্টস থেকে আমরা যে ক্যারেক্টার পাই, সেই জন্য int x, y, z, that means x is a integer, and if value of x is integer, then obviously y will be integer, then again z will be integer. So it is inherit from the x. That's why you can say z is an integer when we write int x, y, z. So this is the inherited attributes, and for this we can prepare a dependency graph. See, real PQ. That means what? P is a real. This is written in a Pascal-like language. That's why it is real. Or nowadays you can say it is float. So float PQ. Then how it is possible? P is a float, okay, but how Q will you float? Because this q, the value of q will be inherit from the p, and from this particular sentence we can write the first tree d t l is real, l l I d I D. So these are the real pq, and there is a dependency. See, when identity is p and if p is real, so what will be first? The t dot type is real or integer. That should be first identified. Then this will go to the L dot in. L dot in is a real. If it is real, then L dot in will be real. Then this will come to the L1 dot in. If it is real, then this will be real. And at type also Q will be real. Right? The Q will be real. How it will possible? Q is real because T is real, because this Q is depend on the T. This Q is depend on the L. L is depend on the Q. So that is dependency curve. And in this way, how P becomes very real? Because this P is depend on L1 real. L1 is real, so it depends on L, and L depends on T. So in this way, this inherit, P will inherit the real, and again Q is inherit on the real. So this is the inheritance graph or dependency graph. And some syntax tree can be generated using the make node. Make node like a one type of linked list. You know the linked list, plus, minus, and in pointer, key pointer. So using this pointer and plus and minus, so one node has been created, and leaf will be created, and we can generate some, we can prepare or produce some syntax tree using node, make node, and make leaf. This way we can get some more. So obviously syntax tree can be generated by the dependency graph. So these are the syntax tree. Say A minus 4 plus C. What will happen? See the linked list. This is a linked list. Here entry is A. There is 4 ID. So these are the production. First this will depend on this and this. Then this will depend on this and this. The first value will be stored. This is ID noun. So this pointer is ID. This is a noun. Then it becomes here and ID. So these are the simple example of the syntax tree using the make node and make leaf, yeah, using the linked list feature. And using this we can create some directed acyclic graph for the expression. Suppose this is the expression A plus A star bracket B plus C plus B plus C. So B plus C are common, multiplication also common. So using this we can create some directed acyclic graph. For the directed acyclic graph, only we can use A only one place. So A is here only one place. And from A, this A will add it with this here and A will again multiply. See A plus A star. So A will add it with here, A will multiply. Then there is a B minus C, B minus C. So B minus C will be put only the position of B and C. So B minus C, this is B minus C. Then that B minus C has been used with multiplication of A. So it will go to the multiplication of A. Again B minus C used for multiplication of D. So this will go to the multiplication of D. Then it will be addition and then this will become addition. Finally we get this. So this is a graph where only A, B, C, D is required only one position and only one single position, and then we can use the graph for the particular expression. So these are the DAG or directed acyclic graph. So basically, that has been done. Just speaking, see the canonical LR collection of the grammar. You know the already you have learned how to uh, create some canonical LR grammar. So these are the LR grammar I0, I1, I2, I3, and using the arrow. So this is the basically nothing more the dependency graph. Who will depend on which production? Say I0, I1 is dependent on I0. Say I9, I9 is dependent on I3. Say I13, I13 depend on I10, I10 is depend on I5, I5 depend on I. So that type of graph can be designed using the canonical Euler grammar. And this using this production, obviously use bottom up evaluation, and using the bottom up evaluation using digit, lex digit and digit. So people can say suppose 5 plus 3 into 4, these are the input symbols. Then using the bottom up evaluation process and stack. So any and the semantic rule, you can perform some action using the LALR or CLR or SLR person table. Then this value has been calculated, and finally we have to see that 17 has been calculated because these are the result and this is the value, and these are the step by step calculation has been shown here. Okay. So this is the a part of the semantic analysis, what's called the syntax directed translation. Now you can ask questions. If you have any question, then you can ask.